Okay, for the next few classes, we will be, let me pick up our laser pointer first. Okay, so for the next few classes, we will focus on a particular language called structured query language, abbreviated to SQL, and more commonly just referred to as SQL. So we'll be focusing for the next few classes on this language. And it is like studying any other language. There are elements of nouns, verbs, rules of grammar, how do you construct a grammatically correct sentence and all that. So as we get into the nitty-gritties of the language, you will find that it has parallels to learning any new language. But before we get into the details, let's first get a sense of what does this language do, and why do we need it at all. So to understand that, let's first take stock of where we are in the course. What do we know up to now? So at this point in the course, we have learned how to start from the information requirements of a business application and come up with the structure of the underlying database that will support the business application. Okay, so we went through this journey where we started from the business data requirements, usually expressed as a narrative, and then from that we had the logical model expressed as the entity relationship diagram, and then we saw how to translate that logical model, the entity relationship model, to the relational schema, which is the physical model. So at this point, we have a blueprint for the structure of the database that we want to implement. And we had a little discussion of how the relational data model is a standard structure that one can use to express the relational schema for any particular application. So to use our building, this analogy of constructing a house, at this point we have a blueprint of the house that we want to construct. So we have a blueprint for the structure of the database using the relational model. And then, of course, the last step is to actually put it on disk, to actually physically implement that blueprint. So again, going back to our housing analogy, this would be very similar to starting from the blueprint and then having a contractor talk to the electricians, to the carpenters, to the masonry people, and actually get the building constructed. As you can imagine, in construction, there's a certain language that contractors use to talk to electricians, to carpenters, to the masonry people, and so forth. Otherwise, they wouldn't understand what needs to be implemented. We have a similar situation over here. So as I just said, at this point, we have a blueprint for the database structure that we need to implement. So that this is where we are. We have the blueprint, and now we actually have to physically implement it on the computer, on secondary storage, and so forth. So how does that get done, and who does it? I think we mentioned that in one of the previous classes. This piece of software, this database management system, is the agent. It's the entity that actually manages the structure. Okay, so when we say manages the structure, what kinds of things does this agent, this database management system software, what does it do? What does it mean to manage this database, which is a structured collection of data for which we have the blueprint. So of course, the very first step is to create the database. Okay, so this blueprint, this structure that we have, that empty shell, that structure needs to be created, and that's the first step. The database management system does it creates the structure, and then once the structure is created, you can easily imagine what the next steps would be. We would go ahead and populate that structure with actual data. And then once the database is populated, the actual operations start. And given that this is an airline reservation and business application, the actual operations would start. So this database management system, excuse me, would help us in adding, doing operations like adding data to the database, adding a new customer, adding a new flight, etc., deleting information from the database, let's say a customer canceling a reservation, or an airline getting rid of a particular route, so deletion of data. It also helps update various contents in the database. So let's say a customer wants to change the date of their flight. That would be an example of an update that's done to the to the database contents. Okay, so broadly speaking, in terms of what the database management system does in terms of managing the database, one of the major things that it does is it first creates the structure as per the blueprint. So we have the blueprint. So the first step is to have this get this software agent, the database management system, to create that structure. And the second type of action operation that it does is it manipulates the data once it's created. In order to do both these two types of activities, that is, create the database and then operate on it, we need a language to talk to the database management system. We need to give it the instruction in order to do its thing. Okay, so there are two sort of categories. So this language called SQL, structured query language, it really has two parts, okay, to it. And I think once I mention what those two parts are, you'll easily get an idea of why those are there. One is called the DDL, and the other is called the DML. So these are two different parts of SQL. So SQL is a language to talk to the database management system to get it to manage the database. So you can imagine what the abbreviation DDL stands for. It's data definition language. So just as the acronym implies, it's a language, it's a part of SQL. It's a data definition language which allows the database management system to create the database structure, the relational database schema. This database plan, relational schema that we have, in order to implement it, I meaning the database designer, will talk to the DBMS, give it instructions on how to create this database, and the language that I use to communicate with the DBMS to instruct it on the structure of the database is called DDL. So that is what we will be concentrating on in this class. And then in subsequent classes, lectures, we will focus on the second part of second piece of SQL, which is DML, data manipulation language. And that's the language that we use to instruct the DBMS to add content to the database, to delete content from the database, to change various values in the database. So that's the second part. That will have to wait. So for now, we will concentrate on this data definition language. In other words, the aspect of SQL that helps the database management system create the relational database structure. So before we get into the nitty-gritties of the DDL, as with learning any language, we'll find that there are some sort of irritating, annoying aspects to a lot of fine details that one has to keep track of. And usually there are manuals that will help you do that. But it always helps to keep the big picture in mind. That is, what does this language do? As I said at the beginning of this lecture, that one of the things, before getting into the details, one of the things we need to know is what does this language do and why do I need it? So what this language, this DDL piece of SQL, what it does is it helps create the database structure. And why do I need it? Because the software is going to do the implementation. The software is actually going to take this blueprint and put it on disk and actually in physical storage. But in order to do that, I need a language to talk to the DBMS, and that language is the data definition. That's the why. Why do I need this particular language? Because I can't talk to it in the language of bits and bytes. That's too fine a level granularity to talk to it. Okay, so the DDL will contain instructions. It will contain pieces, aspects of the language that helps me instruct the database management system, hey, this is how you go about constructing the structure of the database. So in order to understand what kind of instructions, what kind of characteristics would this data definition language have, let's take a look at a plan for a database, a relational schema, and just go through a little reasoning and ask ourselves, what kind of things should this language be able to do? What should this language, what characteristics should it have? What features should it have? What abilities should it have in order to be able to implement that relational schema blueprint. So here is a sample relational schema. The reason I'm using this is just to again point out to you what are the kinds of things that the DDL should be able to do. This language, what characteristics should it have? So first of all, the DDL, right from this diagram, you can see one thing that the DDL should be able to do. I should be able to give instructions to the software to be able to create a table. So we know that from the relational schema, one of the basic components of a relational database is a relation, which we can think of as a table. And in order to create the table, what should the DDL be able to specify? It should be able to specify what are the names of the attributes of the table. It should be able to specify what are the data types. Remember, we talked about attribute domains in a previous lecture. So the language, the data definition language, should be able to tell the software, hey, I want to build a table called course, and that table should have such and such attributes in it. Here are the data types for each of these attributes. And remember, one of the aspects of the relational model we said was every entity must have a primary key. You see this little picture of a key up front. So another thing that the data definition language should be able to do is I should be able to tell the software via the data definition language that this table called course has a primary key called course ID. Okay? And of course, we know that the primary key cannot be null. So another thing that the data definition language should be able to do, for example, here you can see that department name is a foreign key. We have introduced the concept of a primary key and foreign key earlier in one of the earlier lectures. But you can see in this diagram, here is department, the entity department, and department name is the primary key. You see this little picture of the key in front. And then you see department name again over here. So this is a foreign key. A foreign key is an attribute, which is the primary key of the related entity. Okay. So another thing that characteristic, a feature that the data definition language should have is it should allow me to tell the database management system, hey, build this entity called teacher, and this attribute called department name is actually a foreign key. So I should have the ability to tell the software that this particular attribute is a foreign key. Okay. So what are some of the other things that the data definition language should be able to do? From time to time, I may want to alter the structure of the database. Okay. For instance, for this entity called student, so let's say the database has been implemented, it is working happily along, and 2-3 years down the road, the university decides, hey, as far as the student goes, we should have an attribute, we should add an attribute that records the date on which the student was admitted to the university. So admit date is an attribute. So I might want to change the structure of this entity called student by adding an attribute. Okay. Or there might be reasons I want to delete an attribute down the road. All right. Or somewhere down the road, I might say, okay, this department name, 30 characters is not long enough. Maybe I have a center that has a very long name. I want to change this department name, the data type, from variable character 30 to variable character 50. Okay. So essentially what I'm getting at is another additional thing that the data definition language should allow me to do. It should allow me to change the structure of the database from time to time as needed, because the information needs of a business application never stay constant. They keep evolving over time. And this language, this DDL language that I have, should have the ability to allow me to tell the database management system what kind of changes I want made to the structure of the database. Of course, there are limitations in how you can do these structural changes, but that we will see as we go along. So what I wanted you to get is, so here's, let me, before I move on, so here's another thing that the data definition language should be able to do. Here you have an entity which has a composite primary key. You can see these two attributes, student ID and teacher ID, both having keys next to them. So remember we said that an entity can have exactly one primary key. So these two keys, the symbol, they don't mean that there are two primary keys. It simply means that these two attributes together constitute a composite key. So this language called the DDL should allow me to tell the database management system, create a table that has a composite primary key. So there are all kinds of other things that the data definition language should also be able to express in getting to in allowing the designer to communicate and have the blueprint implemented. We will see those as we go along, but I wanted to go through this example so that you keep in mind you have a high level idea of what is it that this language DDL should be able to say and do. And then when we get into the nitty-gritties of the language, here's the first word of an instruction, here's the second word of an instruction. So all the little details that we have hopefully will make more sense to you. Okay. With that, let's start off and get a sense of what kind of instructions are included in the repertoire of this DDL. What does this language look like? What does it really consist of? So in terms of the different pieces that we will cover while we are talking about DDL, I've already described to you what the data definition language is. It is a language, it's a part of SQL that allows me to communicate with the database management system and create that template and create that relational database, the blueprint for which has already been designed as part of the data modeling process. While we are starting our discussion of DDLs, we will discuss what are database objects. These are the things being created. How do you create an object, and how do you modify an object? So we already saw in the preceding discussion, what kind of modifications might be necessary. We also got a sense of what these objects might be. We talked about the entities and what goes inside an entity. So I hope you already have an idea based on the little example that we saw, this particular example that we were discussing for the last few minutes. I hope you have an informal sense of what are the objects that need to be created, and then we will actually go ahead and take a look at how the DDL, what was the grammar in the DDL for creating those objects in the process of creating the database. Okay, so what are the different kinds of objects that need to be created in the course of creating the database structure? So number one, the database itself has to be created. So a database is simply a collection of relations, and the relations are associated with one another. So I need to be able to tell the database management system, create a database. And once that happens, the database management system will set up the infrastructure that is needed to create the tables and the connections among them. So one of the objects that you can create using the DDL is the database. That's sort of the overall shell that will hold the tables and so forth. So another type of database object that you will create is the table. So within the database, a database consists of, this is, as I said, we were talking about relational databases. That's the standard data model that we are using. So since a database is a collection of related tables, so one of the objects that you will need to create is a table. And then we saw in our example that tables, any table, for example, course, teacher, and this other table called take, all of these tables or entities have attributes. Okay, so another database object that I need to be able to create is an attribute, which is a column. And I also need to be able to create constraints. Okay? By now, you already know that certain types of attributes have to be unique, like primary keys have to be unique. And then we have this concept of a foreign key that connects one table to another. Okay? So I need to be able to express those requirements, those properties of attributes to the database management system, and those are done through constraints. So this language called the DDL should allow me to create these different types of objects, and then we will see what is the grammar that's required to create each one of those types of objects. Okay. So the general grammar for creating an object is you actually use the word create. This is what's called a reserved word. It has a special meaning. So you should not be creating a table whose name is create. You should not be creating a database whose name is create, because it's kind of a reserved word. It has a special meaning to the database management. It's like a command that you give to the database management system. So the grammar, as I said at the start, when you're learning a language, one of the uh, characteristics of any language is its grammar. So when you write a sentence in a particular language, depending on the grammar, the different pieces of the sentence have a certain meaning. So here, the generic format or the structure in which you create a database object is you use the word create, then specify the type of database object you're creating. Is it a database? Is it a table? Is it a column? Or what have you? And then you give a name to the object that you're creating, and then end it with the word go. The reserved word go actually executes that command. Okay, so here are a couple of examples. When I want to create a database, I will say create, that's the create command, and I actually use the word database. That's the type of object that I'm creating, and then I give it a name. That's my own created name. So if I think of this, but suppose I think of this entire big database as the registration database. All right. So that's just sort of a name I made up over here. I'm thinking of this entire database as the registration database. Then what I would say over here is create database registration go. As soon as the go is executed, what happens is that the infrastructure needed to create all those different tables, columns, and so forth that make up the registration database, the infrastructure would be created. The tables are not yet created, but in order to get the database going, there is some background housekeeping work that needs to be done. And this command, create command, will actually create database command, will actually create the database. Okay. Now, again, going back to our example, suppose I wanted to create the table, the entity called teacher, then I would say create table teacher, and then I say go. As soon as I do that, what the software, the database management system does, is it creates a shell for a table called teacher. Okay. Notice that just by saying create table, it doesn't know what columns that table. I haven't yet told it what columns the table has. I haven't yet told it what's the primary key, what are the different attributes. Those things can be filled in gradually, or it can be done in one shot. We will see that later. But this is the syntax, okay, the grammar for creating a particular entity. So I would say create table teacher to create the teacher table, that the shell of the teacher table. Okay. Similarly, if I wanted to create a shell for the student entity, the student table, I would say create table student and go. So in order to create any database object, we use the term create, okay, and then give the type of the object to be created, and then give it a name. Okay, so that's the create command. Now here are some constraints that you need to follow when naming objects. Two database objects cannot have the same name, so there cannot be two databases that have the same name. All right, and then within the same database, no two tables can have the same name. Otherwise, there'll be it's like having two entities with the same name. There'll be confusion as to which one you're referring to. So within a single, so let's say within our registration database, going back, if I think of this entire collection as the registration database, within this one database, I cannot have two tables with the same name. Now, if I think about two different databases, so I have registration and I have another database, then across those two databases, you might have two tables with the same name. But within a single database, you cannot have two tables with the same name. That's a restriction. Okay, and that makes logical sense, of course. And database objects, so whether it's a table or whether it's the database itself, the creation happens only once. You only create it once, and then you use the database object for whatever use it is that you want to put it to. Okay. So a little while back, we introduced the create table command, but we didn't have all these details next to it. It just said create table followed by a table name and then go. And I mentioned at that time that all that command does is it creates a shell called whatever the name of the table is, whether it's student or teacher. But since you haven't yet told the database management system, it doesn't know what columns to create for the table and so forth. So this syntax that you're seeing over here is a further refinement of the create table command. So, and at the very start, when you create the table, you could say things in addition to the table name. So here, let's look at the little pieces. You say create table, you use those two reserved words, then give the name of the table, the name of the entity, and start listing the columns. Okay. So going back to our example over here, if I was creating the student table, I would say create table student, and then I would list these different attributes, these different columns, and the data types for each of those columns, right? So that's the syntax that you're seeing over here. You would say create table student, and then the name of the first column, what type of data is it? Is it character, variable, character, and so forth? And you go along this way for each of the columns. Now, next to the data type, you see these two options is null, not null. That means you can specify whether that particular column, this attribute, has to be null or it's allowed to be not null. Okay. For instance, again going back to our example here, suppose that we want that a student must have a department name, that this particular column called department name cannot be blank or cannot be null, cannot be unknown. Okay, if that's a business rule, if that's how this university operates, then when we specify that column department name, we would say department name not null. Okay, and I think you can guess what kind of attributes would be not null. So if a particular attribute is a primary key, you must specify it must have be a not null. Okay, so here's a specific example. I'm creating a table called employee. Let me pick up the pen here. So I'm creating a table called employee. So just imagine that there is a table called employee. So the first column is employee ID. That's this guy. And I'm telling the database management system that the employee ID cannot be null. I'm saying it's not null. Because I think you can guess why that is. Employee ID at some point will be specified to be the primary key, and the primary key cannot be null. Okay, so not null. So last name, this next column is last name. And I'm also specifying it not null, meaning for an employee to be added to the database, I must know the last name. I cannot have a null value for the last name. I cannot have a null value for the first name. And this is very interesting. So the middle name over here is also specified as not null. And we know that not everybody has a middle name. So why is it that this particular column is specified as not null? If it is specified as not null, that means when I enter a new employee, I have to put a value for the middle name. Okay, so typically what that means is you usually be required to specify something like NMI, no middle initial. Okay, so my preferred thing would be to say that this is null, that a null value is valid for a middle name, but that's not how it's been specified over here. Okay, so a start date for the employee, that makes sense also. If I have a start date, an employee must have a start date. Now suppose there was an attribute called end date. That means the date that the employee left the company. Then end date should not be specified as not null because it's a current employee, they haven't yet quit. So it must be possible for the column called end date to be null. Okay. Now here's the next column, which is spouse ID. It's 10 characters long, and the manager ID is also 10 characters long. Okay. Now these explanations in green, you can see these they are preceded by these double bar, these hyphens. These are comments. Okay, these are comments, and we've used it in this example just to explain to you that when these instructions are being given using the data definition language. So this is an instruction, a create command instruction that would be given through the data definition language. It's part of the data definition language. Now, it's a good idea to put in comments judiciously as and when needed for our own benefit. That is, somebody looking at this command, looking at this design would know what this particular column or attribute meant. So it says spouse employee ID. It says spouse's employee ID if married to another employee. Obviously, not all employees are married. Hence, a null value is allowed for this column, spouse ID. Okay. And then this last column, which is manager employee ID, this is the ID of the manager of a particular employee. And every employee must have a manager, okay, except perhaps the one at the top. So every employee must have a manager, and that's why you see not null over here. So I hope you're beginning to see how this command, this create command, is being used. In this case, we are creating a table, and we are gradually filling in details about the table that's going to be created. Okay. Now let's come to modifying a table. It's very important to understand that when we say modifying a table here, we are talking about modifying the structure of the table, how many columns it has, things like that. We are not talking about modifying values in the table. We're not talking about changing the price of a ticket and so forth. So when we, at this point, with data definition language, all we are focusing on is not the content of the database, but its structure. Okay. So when we say modify table in the context of a DDL, we're talking about changes to the structure characteristics of the structural characteristics of the database. Okay, that's what modification means over here, and that modification is done through the alter command. So the syntax for altering the structure is alter table, and then you give the name of the table and you specify what kind of alterations you want. Okay, so what kind of alterations might we want to the structure of a table? I think I mentioned some examples to you. So I said, suppose sometime down the road, I want to add a column to this table which says the date that the student was admitted. So I could have a new column called admit date, and its data type would be date. Okay, so that would be an example of an alteration that I might want to make. Another alteration that had to be made not too long ago is when we went from 5-digit zip code to 9-digit zip codes. So that's an example of an alteration where you change the data type. So the column still exists, a zip code, but it went from 5 characters to 9 characters. Okay, so the data type changed. All right. So the kinds of alterations that you can do to a table is you can add columns, you can remove columns, and you can modify some aspects of a column. For instance, you could change the data type and or the null policy. For instance, if you have a column which says null is allowed, you might change it to not null, but that has consequences. Okay, so the null policy and the data type of a column can be changed. The other type of alteration that's frequently done to a table is adding or removing constraints. Okay. You saw a little while back what we mean by constraints. An example of a constraint is the specification of a primary key or foreign key. And one of the ways in which you can modify a table, alter a table, is to add constraints or to remove constraints. You cannot modify constraints. Now, these are details that may be hard to keep track of on the fly, so it's always good to look at some columns, and we'll see that in just a moment. So here's the syntax. we would suppose I want to change the structure of a table in some form. I would say alter table. So this table must have already been created. I cannot alter a table that has not yet been created. So I would say alter table, table name. I give the name of the table. So the example I was using was student, and we want to add a column called admit date. So then I would say alter table student, add, and then I would give the name of the new column, perhaps admit date, and then the data type is, let's say, date, and then I would specify not null, because if a student is there at the university, they must have been admitted on a particular date. I must know that date. Okay, so here is an example of a column that you might want to add to the employee table. So think again of that employee example that we were using. We had employee ID, last name, first name, and all of those things. So let's say at the end, I want to add a column called end date. So I'm adding a column to the employee table. Okay. Then the syntax that I would use is alter table employee, add. That means I'm about to add a column. Say add, I give the name of the column end date. The data type is date, and the null policy is null, meaning the end date could be null as long as the employee is with the company. That end date would be null. The date that they leave, the end date would be filled in, but it should be possible for this attribute to be null. So here's another column that we are adding to the same table. It's the job title code. Its data type is character, and this time it's not null, meaning this new column that we are adding, for every employee there must be a job title code. So here you can see with this example the syntax for altering properties of a table. Remember, this alter is not actually changing the contents of a table, but just but it's structure. Okay. Now, instead of adding a column, if I want to remove a particular column, if I want to delete a column, then I would say, I would start off the same way. I would say alter table, give the name of the table, then I would say drop column, just like in the previous one, you had add column. Okay. Yeah. So when we add a column, we don't say add column, we just add, and then here we say drop column, and here we have the column names. Okay, so here we have alter table. We have the employee, the name of the table is employee, and the column that we want to remove from the structure of the table is spouse employee ID. So we say drop spouse employee ID. Okay, so there are some constraints. You can't drop each and every column. So columns associated with existing constraints, so primary key, foreign key constraint, cannot be dropped. Okay, so if you want to drop a column which is associated with an existing constraint, we haven't yet seen examples of constraints yet. We'll see that in a couple of minutes. But if you have a column associated with an existing constraint, then in order to drop that column, you first have to remove the constraint and then drop the column. Okay, so there are some constraints. So with all these examples that you're seeing with the data definition language, this grammar, and later on it's even more detailed with the data manipulation language, it's not possible to memorize these grammars, the syntax. Okay, the best way to practice this is to use the SQL Server implementation, the download the software, implement it, and actually try it out with the database examples that have been, the sample databases that have been given to you. There's really no, unless you do this all the time, which is perfectly normal, that you wouldn't remember all the syntax, but it helps remember the animal structure. So when you're actually going to do it, you know what to expect by way of structure, and there are always manuals to help us to do these things in practice. But at this point, we're trying to understand the grammar, so examples are helpful for doing that. Okay? So now, just like we had add columns. We could add columns to a table. We could drop columns from a table. So we could drop columns, or we could add columns. Okay. We can alter columns. You said add, drop, alter, but there are restrictions on what kind of alterations that you can do. But the general syntax is you specify the name of the column, and then specify the. So one type of modification that you can do to a column is you can change its data type, and you can change its null policy. Okay, so here's the change that we want to make. We have a column, two columns, the three columns called first name, last name, middle name, and we want to change them to variable character 25. So we want to expand them. Okay, and we also want to modify the middle name to allow for null. Remember a few minutes back we were going through this create table command, and when we came to middle name, I said it was odd that the middle name said that it's not null, because not everybody has a middle name. So here we're saying, okay, maybe I made a mistake. I want to now allow for null values for the middle name. Okay, so I want to modify the middle name to allow for null. So here is how I would do this. This is an example. So I would say alter table employee. That's the table that I want to change, and what kind of change do I want to make. I want to alter a column in the table, that column being first name, and I'm changing its data type to variable character 25, and it cannot be null. Okay. Similarly, alter table employee, alter column, last name, variable character 25, not null. Then for the column called middle name, is variable character 25, but I'm allowing for null values. Notice that I'm trying to change the characteristics of three columns. I can't do all of them in the same command. So each column has to be changed separately, independently of one another. Okay. So here are some changes, or rather constraints, for modifying the properties of a column. SQL Server only allows for one column to be changed at a time. We already saw it here. So these are the three columns we want changed, but I needed to issue three separate alter commands. Okay, otherwise it doesn't allow for all three to be changed in one command. Okay, the name of a column cannot be altered. If you want to alter the name of a column, you have to create a new column with the new name. You want to copy the data from the old column to the new column, and then delete the old column. You can only delete and add column. You cannot change the name of a column. Okay. Certain columns cannot be altered. Okay. For instance, the primary key and foreign keys cannot be altered, and that makes sense. Remember when we discussed the relational model, we talked about the entity integrity rule and the referential integrity rule. Those two properties are absolutely central to the validity and integrity of a relational database. So they don't let you mess with those two types of columns, primary keys and foreign keys. Okay. So if by whatever reason you need to for whatever reason you need to modify or alter columns which are primary keys or foreign keys. For instance, you may want to change the name of a column that is a primary key. You have to delete the column, create a new one, and then recreate the key. So to alter columns associated with keys, primary or foreign keys, you delete the key, alter the column, recreate the key, and then you have to repopulate things back. Okay, so it's a fairly tedious process of making those kinds of modifications when it comes to keys, primary keys or foreign keys. Okay? So another type of modification that one can do to a table is to add and drop constraints. Okay, so we'll see in a minute what we mean by constraints, and when we'll see examples of it. But first, the syntax: how does one express using the DDL? How does one tell the database management system that please add this constraint to a table? Okay, so we start off with alter table, give the name of the table, and then start adding constraints. So add the constraint. Now look at the syntax, the structure of a constraint. You actually use the word constraint. It's like the reserved word create. When you say add constraint, Then the database management system knows via this syntax for the DDL that it is about to create that kind of restriction on a particular attribute or combination of attributes. So after using the word constraint, you follow that with a name. For every constraint must have a name so that you can later on refer to that constraint. So you would have the name of the constraint followed by what that constraint actually is. Okay. And you can string several constraints together, one after the other, right? So this is the general syntax for adding constraints to a table. Let's now see some certain other types of modifications that one can do in addition to the constraint. So here is sort of a variant of the constraint. We say alter table, give the name of the table, and then we say add constraint, give the name of the constraint, and here is the constraint we want to add. We are saying that this particular column that we are naming over here has to be unique. So we are saying please add the constraint that this particular column is unique. Okay, and notice that you could specify more than one column. So you can see column name 1 and then column name 2, column name 3, separated by these square brackets. Okay, what's the difference between specifying one column and two? If you specify more than one column as unique, so suppose we put 2 of these columns here, what I'm telling the database management system is that the composite value is unique. Okay, so let's see a particular example. All right, so we have a table called student. We have already created it with all its columns and so forth. And student number, the student social security number, is the primary key. We know that it's a candidate key, and social security number is unique. We know that. No two students would have the same social security number. So here is what after creating the table student, I'm telling the database management system using this command. I say alter table, add constraint. I give a name to the constraint. This is the it's on the student student social security number, and I tell the database management system that the constraint I am adding is that this column student SSN should be unique. In other words, if I look at the student table, no two students should have the same student SSN. Whether or not SSN is a student SSN is a primary key is irrelevant at this point. The reason I'm putting student SSN as unique is because I know that student social security numbers are unique. So I should never have 2 students in that table that have the same social security number. Okay, so this is a situation where the unique value is associated with one column. So let's see what happens when the unique value is associated with the composite attribute. So here we have a table called registration. If you remember, maybe in the last lecture or the one before that, when we were discussing surrogate keys, we had, let me pick up the pen over here. When we were discussing surrogate keys, we had a table. I forget what so the name of the table was registration. And it had these 1, 2, 3, 4, 5, okay? These 5 attributes, and all 5 attributes together constituted the primary key. So it was a composite key, a primary key consisting of 5 attributes, okay? And then we said that, hey, this is really messy to handle, and that's when we created a surrogate key called CRN, okay? So that because the composite key was just getting too big. Typically, if it's more than 3, then it's considered too big, and it's maybe a good idea to put in a surrogate key like we had here. It was CRN. But for now, for our discussion here, let's say we didn't have a surrogate key, and I want to use this composite of 5 attributes to be the primary key. And here is how I would specify it. I would say alter table. The name of the table is registration. I'm saying add a constraint. here is the name of every constraint must have a name so that I can refer to it when needed. This is the name of the constraint. And then I say unique SUBJ C number section 7. So notice that there are multiple columns that are listed over here. Okay, so multiple columns are listed. That's what this syntax means over here. Unique column name 1, column name 2, column name 3. So you could have multiple columns listed there. So what this command is telling the database management system that the combination of these 5 attributes should be unique. So these 5 attributes together. So you could have 2 rows in the registration table where the subject number is the same, where the course number is the same. You could have 2 rows in the registration table where the calendar year is the same, but you will never have 2 records in the registration table where all 5 of these attributes are the same. Why? Because those 5 attributes together are supposed to be unique. That's what this constraint is specifying. Okay. So here is another type of constraint that one can add, and this is where you specify a column or a combination of columns to be the primary key. So we say that here's the grammar or the syntax. We say alter table, give the name of the table, then we say add constraint, give a name for the constraint, and then we say the words primary key, and follow that with the names of the column or columns that constitute the primary key. Okay, so one or more columns can be specified to create the primary key. If more than one column is specified, so if you have column name 1, column name 2, and so forth, then it's a composite primary key. You can only have one primary key per table, and columns that are used to create the primary key cannot be null. So you can't remember the entity index which says the primary key cannot be null. So if your primary key is specified, whether it's 1 column or 2 columns or 3 columns, you cannot have null values for the primary key. Okay. Now this constraint name, every constraint must have a name. If the constraint happens to be for a primary key, typically the constraint name, you start with the letters PK. You don't have to do this. The constraint name can be anything, but just for the sake of understanding the command and to understand the structure, this is a helpful way of naming the constraint for a primary key. Okay. So here's another example. Let me pick up the pen over here. So I have a table called student, and I have an attribute called G number. I think we discussed this maybe last session or the one before that, where we decided that the G number was the ideal primary key for the student rather than social security number or telephone number, things like that. So this G number in this is the ID for the student, the primary key for the student. So this is how we are specifying it in the through the data definition language. We say alter table student. So the table student has already been created. This additional command that I'm giving, which says alter table, I say alter table add constraint. I give the constraint a name. Every constraint must have a name. So the name that I'm using is PK underline student. That's just to remind me that this constraint establishes the primary key of the table student. And then I say primary key G number. That's the name of this column. I should have written G number here rather than G num. Okay. Now, if I have a composite primary key, so I have a table called course. This is also an example that we had used earlier. So course, you have a subject prefix and then the course number. So you have subject prefix and then course number like MIS 330. So the primary key is the composite of these two together. Okay. So the way you would specify that using the alter table command is you say alter table, give the name of the table, which is course, and then you say add constraint, follow that by the name of the constraint, and then you say primary key, and you put both the columns together as the primary key. As soon as you see more than one column, this doesn't mean that there are two primary keys. It simply means that you have a composite primary key consisting of these two columns, that is the subject prefix and and the course number itself. Okay. So now that you've seen how to specify a primary key as a constraint in the case of for a relational database, the other type of key that you can have is a foreign key. We discussed that when we are talking about the relational model in the very first lesson. A foreign key allows you to connect two tables. It points out the association or the connection between two tables. So there are always two tables involved when specifying things with a foreign, specifying association between tables using a foreign key. So what's the syntax? What is the grammar by which you use the DDL to tell the database management system, hey, I have a foreign key here that connects two tables, okay? So you start off the command by saying alter table. This is the name of the, followed that by the table name itself. So remember, this table must already exist. All I'm doing now is I'm modifying its specification to identify the foreign key. So then I would say add constraint. Every constraint must have a name, so I follow that by a name. And then I actually use the word foreign key. Just like in the previous example, you saw I actually used the word primary key. Now you use the word foreign key. And then you have a list of columns that constitute the foreign key. Then you use the word references, because remember, foreign key is used to connect two tables. You say references, and then you give the name of the table that is referenced through the foreign key, and you give the columns in the reference table. Okay, so these sets of columns here and the sets of columns here must match exactly. Okay, so let's see an example over here. So the two tables that we have here. So let's see what kind of linkages are being specified through the constraints over here. So we say alter table registration, add constraint, and then foreign key references student. So as soon as you see this foreign key, pick up the pen over here. As soon as you see this particular constraint for a foreign key, you know that two tables are involved. Okay, so here is one table, here is the other. So reference is student, so I have the student table. Okay. And we know that the primary key for student is gnum. That's the primary key. And then here you have the table called registration. And we have a foreign key called student G number. Notice that these two are the same G number for the student, but the names of the columns are different, which is perfectly fine. So what this constraint is saying is, in the table registration, I have a column called student. This column must already exist in the creation of this table, and I'm saying that this column called student G number references G number, which is the primary key of student, of the table student. So a foreign key, remember just the definition of a foreign key. A foreign key in a table is an attribute in the table that is the primary key of some other table. It does the linkages. The foreign key links one, it's a parent-child relationship, and the foreign key links the child to the parent. Okay, it's in that direction. So that's the linkage that you have drawn in pictorial form. This is the linkage that you have. So in the table registration, the foreign key called student gnum connects the registration table to the table student. It references the table student. So here are the different pieces of the grammar. Alter table registration. So here's the table. I'm telling, using the DDL, that I want to change the constraint on this attribute, on this column. So I say alter table registration, add constraint, foreign key student G number. So this is a foreign key. It references the primary key of another table. So it references, here's the other table student, and it references the primary key of student. Okay. Similarly, if you look at the second one over here, it says constraint. So here's a second constraint. Okay. So foreign key, subject, and course number. So you have two other. So let me pick up the pen over here. So you have two other columns in the registration table. So we are still talking about the table registration here. So there are two other columns, one called subject and the other called CNUM. And what this references is course. So you have another table called course, and its primary key is composite. The primary key is subject and course number together. So it's a composite primary key like MIS 310. So this is a composite primary key. Okay. So in this case, this particular constraint, what we are saying is the foreign key, this is a composite foreign key. Here's the foreign key in the table registration. It references the primary key of the course table. It references course, the table course, and these two columns. So you see that this guy and this guy must match. Similarly, this guy and this guy must match in terms of data type. Okay, so it doesn't matter that the names of the columns are different, that the names are different over here. The data types must match. If this is specified as character 10, this must also be specified as character 10. That kind of matching must be done. So you've seen that a very common type of constraint that is added to a table while modifying it is to add constraints. And in this case, you saw three examples of constraint. Now, how to set up a primary key and how to set up a foreign key. Okay, or if you want, third example that we saw is to specify a particular column as having a unique value. Okay. So here's a slight variation of what we saw in the previous example. Just for reference, what did we see in the previous example? I had one alter table command. So within one alter table command, I had two constraints. One constraint set up the foreign key for connecting registration with student. Connecting registration with student, that was the first constraint. The second constraint connected registration to course. To two separate connections specified as two separate constraints, but within one alter table command. Okay. Here, what we're doing is doing the same thing with two separate alter commands. So that's your choice. It's basically the same statement syntax in terms of the constraint. It's just that we did it with two separate alter table commands, and that's perfectly fine as well. It's a stylistic thing. You can make a decision on which alternative you would prefer, that is setting up two separate alter table commands or having both of the constraints within one alter table command. Okay. Now there are some rules that apply when adding foreign keys. When you're adding a constraint regarding a foreign key, there are some rules that are to be followed. And once you read these rules, you will see that you already know about these through our discussion of the relational model in lesson 1, where we had talked about the entity integrity rule and the referential integrity rule. Okay. So when a value other than null is entered into the column of a foreign key. So if you have a foreign key value, so let's say you have specified a foreign key constraint. If a value is entered for the foreign key then it must match the primary key value in the related table. Otherwise, you get a foreign. So all that this statement is saying is that once you specify a foreign key, then the database management system will automatically take care of referential integrity. If you forget to specify that foreign key relationship, then referential integrity can get violated. Okay. Foreign key constraints can reference only tables within the same database. That makes sense. Two separate databases have no connection with one another. So a foreign key from one database cannot reference a table in another database, but within one single database, one table can reference another through a foreign key. Okay. And the data types must match. So going back to our example over here, I have the foreign key student gene number, so I think picture is better. So here I have a student gene number as the foreign key, which connects registration to student. These two columns, this one and this one, the foreign key connecting to the primary key, these two columns must have exactly the same data type, otherwise the system will complain. Okay. Similarly, registration is connected to course through this composite primary key, through this composite foreign key. So subject number and subject and course number. So if I take these two, and here are the two in the primary key in course, the data types must exactly match. So the data type for this guy must match the data type for this fellow. The data type for this fellow, this column, must match the data type over here. So the data types must exactly match. So the matching of foreign key with primary key is really in terms of the data types. The data types must match. The actual names of the columns may change, may vary a little bit, but should be similar to suggest to you that one is a foreign key connecting to a primary key, right? So you've gotten a sense of what we mean by constraints and how they are added to a relational database. Okay. Now, just as we can add constraints, we can of course drop. That is why constraints have to be named. Okay, because you can refer constraints that can be fairly long in terms of the specification. So it helps to give a name to the constraint because that's a shorthand way of referring to something that could be possibly long. Okay. So just as you can add constraints, you can drop constraints. So here's the syntax for dropping constraint. You say alter table, give the name of the table, use the phrase drop constraint, and then give a list of the constraints you want to drop. So constraint name 1, constraint name 2, constraint name 3, and so forth. So you can drop multiple constraints in one shot. So just like you can add columns and drop columns, you can add constraints and drop constraints. So what have we seen in this particular lesson? We saw the DDL commands. The DDL is a portion, is a segment of the language SQL. We saw the grammar of DDL, how it's used to create a database, how to create a table, and how to create a table with columns, how to use constraints to create primary and foreign keys, and then how to modify the structure of tables using the alter table command. We've seen how to use alter table commands to add columns, to drop columns, to change data types for columns, to change null policies on columns, and how to add constraints regarding primary keys, foreign keys, and how to drop constraints. You cannot modify constraints, you can add and drop constraints. Okay, so this was our introduction to the data definition language, and to remind ourselves what this language does and why we need it, let me get back to the first slide. Okay, so the data definition language is a portion of SQL. It helps us create the database. So obviously, before you can use the database, it has to be created. So this language that we're beginning to learn is the language that I use to communicate to the DBMS how it should go about creating the structure. It's a language that allows me to specify the structure of the database to the software so that it can go ahead and actually implement the blueprint on this. So this is our introduction to the data definition language, DDL portion of SQL.